Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for day 1 of 6.2.5. We need to start with solving some equations. So at this point, we want to be done with the equation maths. We do not want to have to draw any pictures. We want to just understand the basic rules. Remember, the first thing is to look for distributive property or combining like terms on either side. You want to simplify each of those expressions on either side. Once they are completely simplified, then we begin adding or removing balanced sets. So the idea that we would take away 2x's from each side, and that becomes 16 is equal to 3x plus 4. Then we want to get our 3x's by themselves, so we take away 4 from each side, and that would give us 12 is equal to 3x. And now what do you multiply times 3 to give you 12 for an answer? Well, multiply 4 times 3. So if we check it, 2 times 4 is 8, and 8 plus 16 is 24. On this side, 5 times 4 is 20, and 20 plus 4 is 24. Very good. We feel good about our answer. We draw a box to declare our answer. Here, take away 1x from each side and add 5 to each side. You get x is equal to 19. So this becomes, what is 19 times 3? 57 minus 5 is 52. And 38 plus 14 is also equal to 52. Trust me on that. So this is the correct answer. And here we're going to add, now let's take away an x from each side to give us 4 x's. Let's add 5 to each side to give us 20. 4 times 5 is 20. Yes, it is. So 20 minus 5 is 15. And no. It's not 20. It's supposed to be 5 times 5 is 25 minus 5 is 20. And then 5 plus 15 is 20. Yes, it is. So we know we got our answer correct. All right, write an algebraic expression for each situation. 3 less than a number. The most common mistake students will make is they'll want to put the 3 first. So when you have a less than scenario, knowing that you are subtracting and you can't just reverse the order of the 2 terms that are being subtracted, think of a number. So I always think of the number 10. So 3 less than a number, if I said 3 less than 10, the answer would be 7. So it would have to be 10 minus 7, correct? It would not be 3 minus 10 is equal to 7. So thinking about that, the number that you're thinking of must be listed first. So 3 less than a number means you start with the number and take away 3 from that number. So this would be the way to write that. 9 more than, right? 9 more than means you're going to add 9 to 3 times a number. So in this case, if you had written it this way, it really wouldn't make any difference, even though this is the appropriate way based on what that says. And then 2 less than means you're subtracting 2 from this quantity, 5 times the number. So it has to be 5y minus 2. All right, 5D process. A triangle, draw your triangle, has a base that is 3 times longer than its width. So here's the base, here's the width. I just drew the picture. I did not make it so it was proportional in any way. We're just doing it for labeling purposes. And then it says that the area is 486 square meters. So if we're going to figure out the dimensions here, to do this algebraically is actually really, really hard, because we know that the formula for area is 1/2 times base times height. So this is going to be 1/2 times 3x times x. So 486 is going to have to be equal to 3 halves x squared. So now, what do we do here? Now we have to divide each side by, in fact, let me change that to 1.5 just to make life a little easier for you here. And then I can use my calculator and say 486 divided by 1.5 is 324. 324 is equal to x squared. All right, this is a type of solving equations right there that you have not done before, but I'm going to go ahead and show you right now how to do it. Remember, all of this when we're solving equations is about choosing an inverse operation. If we had the problem that said 4x was equal to 12, instead of multiplying times 4, we divide, and that's the opposite of multiplying. If we had x plus 3 was equal to 5, instead of adding 3, we would subtract 3, and those are opposites of each other. Adding and subtracting are inverse operations. Multiplying and dividing are inverse operations. Well, you know what the inverse of squaring is? Finding a square root. So if we find the square root of 324, we will have our answer. So x times x is equal to 324, which means we're multiplying the same number times itself to give us 324 for an answer. Your calculator should have a button for that, and it's right there. 324, find the square root of that, and you get an answer of 18. But I wouldn't have expected anyone to know that. So that's where the guess and check table comes into play. Just make up a number for x, triple it, and that would be your base, and then we plug all of that into the formula. Take 1/2 of base times height. 1/2 of 300 is 150, which is too low. Make this 20, make that 60. 1/2 of 1,200 is 600, which is too high. So then my next guess, I went down to 18, and that ended up being the magic number, right? Remember when I said the square root of 324 was 18? That would be the number to choose. So this would have to be 54. Turns out 18 times 54 is 972, and when you take half of 972, it ends up being 486. Oh, do you see what I did there? I took half of 18, then multiplied it times 54, and got the same answer. All right, Candy has a bag of marbles. She has 5 black, 3 white, 2 green, and 4 oranges for a total of 5, 8, 9, 10, total of 14 different marbles, or 14 total marbles. What's the probability she will get a green marble? Well, that would be 2 out of the 14, which is a 1/7 probability. If she does get a green marble and does not put it back in, what's the probability that she'll pull another green marble from the bag? Well, that means there would only be one of them in there, and only 13, so that would be 1/13. Assume that Candy does get the green marble and does not return it to the bag. What is the probability she'll pull out another green marble? Well, she can't, because at that point, there are no green marbles left of the 12 that remain in the bag. So that would be a 0 probability of that happening. All right, which of the following represents a proportional relationship? Remember, proportional relationships follow the formula y equals kx. I think we've talked about this. Pretty sure. Can't really remember. I know I've talked about that with the 8th graders. But at any rate, there's a constant growth rate. We must have talked about this before. There's a constant growth rate, and the most important part is that 0, when x is equal to 0, y has to be equal to 0. So there's never going to be anything being added on at the end of this situation. So like, for instance, this portion right there makes it so it's not proportional. 0, 0 is an important part of proportional relationships. And in this case, if x were equal to 0, you would still have 0 plus 2. You'd still get y was equal to 2. So that's not 0, 0, that's 0, 2. Makes this non-proportional. Here it works. When x is equal to 0, and this entire side becomes equal to 0, because anything times 0 is 0. So y would be equal to 0. This is proportional, and the constant of proportionality is the number that is being multiplied times x. And that also, you'll find out, also in this situation happens to be what we call the unit rate. And then here, after you send in the dive bombers, that becomes y is equal to 3x minus 3. And we're not supposed to have anything being added on at the end or even subtracted. So if x were equal to 0 here, you would end up with 0 minus 3, so y would be equal to -3. And that means it's non-proportional. So the only one here that's proportional is that one right there, and it follows in the y equals kx model, where K is your unit rate or your constant of proportionality. All right, a little bit of review here with using a sort of tightrope situation to represent an equation. This quantity here has to be equal to that quantity there because the tightropes are exactly the same length. So this is m plus 1 plus 5 plus 1. So this would be m plus 7, and this is 2m's plus 4. So what value for m would make these exactly the same? Well, let's go ahead and solve that. I would start by taking away 1m from each side, so you end up with 7 is equal to m plus 4. And then when I take away 3 from each side, you get m. No, you don't. Why am I taking away 3 from each side? That's crazy. I need a 0 pair over there. I need to take away 4 from each side, so that zeroes out. So that gives you 3. So m has to be equal to 3. So if that's 3, then this becomes 3 plus 7 is 10. And this becomes 6 plus 4 is also 10. So when m is equal to 3, both of these are equal to each other, which means that we've got the solution. M is equal to 3. All right, solve the equation using any method that you like. Well, let's just use our normal methods, right? Let's start by taking away 10 from each side, so it becomes 3x's is equal to 15. And 3 times 5 is 15, so that means x is going to have to be equal to 5. So x equals 5, and then if we check it, 3 times 5 is 15, and 15 plus 10 is 25. That works. So hooray for that answer. Here, I would rather send in the dive bombers than divide both sides by 5 at the beginning, but you are technically allowed to do that. So just so that you know, if we think about this, 5 times this entire quantity on the inside is 30, which means the x minus 2 has to be equal to 6, because 5 times 6 is 30. So what do you take away from, what number do you take 2 away from to give you 6 as an answer? That must be 8, right? Because 8 minus 2 is 6, and there is your 8. But if you want to send in the dive bombers and do it the way that we've been doing it, go ahead. This case, you would just go through the proper order and add 10 to each side so that these guys zero out. And then what do you multiply times 5 to give you 40 for an answer? Well, let's go ahead and divide 40 by 5, and you will see that that is going to give you 8. So 8 minus 2 is 6. 5 times 6 is 30. Yes, that is the correct answer. And on this one, let's take away an x from each side and add 9. Let's do it all in the same exact step. All right, so these guys cancel, they cancel. 2x minus 1x is x. 7 plus 9 is 16. Does that seem like it should work? 32 minus 9 is what? Is that 23? And then 16 plus 7 is also 23, and they're equal to each other, which means that is absolutely the correct answer. All right, and we are done. Let's go ahead and move on to our next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, walk